So I'll repeat the question. So in the previous lecture, you heard about all these classical AI tools. And you saw this example where the MNIST data set where you give them MNIST to a very simple neural network, just a feed-forward neural network. And even just that gives you good accuracy. Why? Why do neural networks work fundamentally? Going once, twice, thrice. Okay, no comments. Well, anyway, I told the answer to the in-person people. The answer is non-linear activation. So that is the fundamental little math trick that is helping us project the problem into a higher dimension. And then we are able to distinguish, or not we, the machine is able to distinguish and see the difference between two classes. So in fact, in the support vector machine, there's something known as RBF, or radial basis function. I don't know if Brenda ever, or the previous lecturer ever touched upon that, but that is the thing which kind of simulates a non-linearity. But the core idea is we have been trying to make sense of a continuous world using discrete tools. And this is exactly what happened until somebody just came up and said, oh, let's use a non-linear activation. And things are working. And things did not start working. Things stopped working here because our projector stopped. Okay, sharing screen, third time. All right, so yeah. So that was a fundamental idea, and combined with the fact that we had a lot of good hardware coming up at the same time, and people were able to replicate all these huge amount of neural networks in a way that is similar to the human understanding of language minimally, and looks like we can make it extended to a lot of other fields, including computer vision. So I will quickly do a review from last week, which was we had seen what will we do when we need huge resources, and we discovered we can use cybers. And I think we even spoke about reinforcement learning, right? Did we? Yeah. Okay. So then I bring you the next question, which is, we did reinforcement learning. Okay, so this is the second part. Did we do retrieval augmented generation before? No, right? So this was the question Noreen had asked me before, which was, how do you make your own chatbot? All right, so in one of the previous classes, we saw we can make a chatbot with already existing data like the one from Llama trained chatbot. But what if you want a chatbot which is fine-tuned or trained only on your data? So the answer is sure, you can fine-tune it, which means you need the same amount of resources in terms of hardware and time, which people like OpenAI and Google had. But now there is an easy way out known as retrieval augmented generation. And this is probably your best bet if you want to get a quick chatbot working on specifically on your data. So now the base model, in this case, you can see that the base model will be in one of your open source model like Llama or GPT if you have access. And you're asking, what are the name of that movie Chris emailed me about last year? So clearly, LLMs don't have access to your email inbox. At least we are believing it doesn't, at least until now. So LLM says, no, sorry, I don't have access to any specific information about it. And then we gave it this extra data set here, is in this case, all the emails from my inbox. And then we ask the same question, okay, what was the name of the movie that Chris emailed me about? And it gives a right answer this time, that Chris emailed you about the movie The Fall on October 23rd last year. So this is the simple idea of plug in a retrieval-based mechanism. So this is how it will look like. So initially, the user querying looks exactly the same, but the query goes into a model, even before it goes to the LLM here, it first goes into this simple vector DB, which you can think of nothing but like a SQL database. It just retrieves a bunch of documents related to the particular query you're asking. Say, for example, if you are teaching a class on wildfires and your question is about wildfires in Arizona, you can actually go get the chapter on wildfires in Arizona, index it in the vector DB. And what RAG, or retrieval augmented generation, does is it combines the prompt that the user asked and enhances the prompt, saying that the question was, which was the largest wildfire in Arizona? And the way, even though that was the question the user asked, by the time we send it to the LLM, we will rewrite it as, what was the largest wildfire in Arizona? Answer only from this context. And we provide the whole context, which will be that chapter in the wildfire textbook about Arizona. So this was a nice, clean, easy trick, which people have invented. And we also use it in our chatbot we developed for D2L recently. So that is your answer, Noreen. Like, if you want a quick, well-functioning chatbot, take it off the ground pretty fast, this is your way to go. Question?
So is the embedding model in vector, is that happening server side or client side?
Nothing is in client side. All the client does is ask the question.
Okay.
So yeah, we have everything sitting embedding. The first model is embedding model, which simply, let's say, takes the embedding from GPT and converts every single word you asked and brings out the corresponding embeddings of it. Just a translation into the embedding world. And in fact, I think I showed you this thing already, but let's try it again. Just like, I think I shared this with you. This is a chatbot we recently developed for U of A, and here's the same course I was telling you, Introduction to Wildland Fire. And let's ask, which was the largest fire in Arizona? So this is actually a full-fledged course which happens in the U of A, and we have trained it on the materials of that. And this machine is pretty good. It goes, finds the right answer. And it's more, this bot can even do interesting things like, can you give me a summary of lecture on wildfires of Arizona? Maybe I'm probably not asking the right question, but more interestingly, we ensure that our bot doesn't hallucinate. So let me ask you this question. Have you encountered ChatGPT hallucinating? Are you aware of ChatGPT hallucinating? Why does it do that? What?
Poorly trained model.
Sure. I mean, you can probably say you can hit it with more data and hopefully it'll be trained more, but even then it'll do the same thing. Do you know why? Yeah, that's because all these machines are a glorified, find me the next word after the given word, right? So if it cannot find anything, remember, all it is doing is a frequency match. So if your sentence was, I love wildfires in Arizona, all it is doing is how many times did the word wildfire occur with Arizona, right? And for the word wildfire, it'll have a long frequency list. Now, in the given data, especially in your kind of case, like your personal data is known only to you and the chatbot doesn't have an answer. And like the example we saw earlier, what was Chris's email? A normal chatbot currently would say, it will actually hallucinate because it will go look for the word Chris, and in the world, whatever times the word Chris occurred with, it'll start adding one word after the other, and that's what we call hallucination. But this chatbot we built, we did a very simple trick. All we did was the same retrieval augmented sequence. The user asks a query, and we call that a prompt. We told the chatbot, hey, here's the query, answer from this context. And in the end, we said, if you don't know the answer, own up, say you don't know, right? Answer only from this context. We are almost like putting a boundary to its abilities. And then it slowly started saying, I don't know. So maybe, I can ask this chatbot, what was the largest wildfire in India? I'm assuming that they don't teach that here in the US. Perfect. So it says I can't answer this question as there is no information about wildfires provided. So that was the one of the fundamental reasons why we built our own chatbot, because we did not want to use ChatGPT because we are using it for teaching students like a teaching assistant. And if it starts giving hallucinated or wrong information, it beats the whole purpose. This is one of the fundamental ideas. Like when the university contacted us, they said, do anything but don't give wrong answers. Beats the purpose of education, right? If it's confidently giving you wrong answers or hallucinated answers, which is what ChatGPT was doing. So yeah, we were able to solve that issue with retrieval augmented generation. Prompt engineering, which is what I would talk about in a second. We call it, I don't know, have you heard of the term prompt engineering? So in GPT, what people started realizing is that if you ask nicely, it gives the right answer. And this is an example of nicely. So here's initially the question was, Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each has 3 tennis balls. How many tennis balls does he have? Okay, so the ChatGPT says, sure, answer is 11. You ask a similar question. The cafeteria had 23 apples. If they used 20 to make lunch and bought 6 more, how many apples do they have? What will be your answer? Let's see if humans are better than ChatGPT. If the 9, okay, so the answer at least is 9, but the model says, hey, no, 27. The problem is we don't know how it arrived at the first answer, 11, right? This is the big bane of the black box known as neural network. We don't know how it's arriving at. It's doing some crazy calculation using the nonlinear activation functions, projecting it to a plane which you cannot even visualize, let alone understand the calculations. So having said that, people started thinking, hold on, what if I ask you to explicitly tell me how you're doing it? So people started saying, okay, how many tennis balls does he have now? But also tell me, how did you arrive at? It says, okay, Roger started with 5 balls, 2 cans of tennis. So here is the math. And once you prompted the GPT with this kind of training a second before or training a minute before from your own answers, then it started realizing, oh, maybe that's what he's expecting me to do. So you see, right, this is a beast which has no idea what it can do with its power. So we are trying to like channelize it nicely and helping it understand this power it has. Doable, but is it really understanding? That is a different discussion. So other uses of all these GPT things these days is in multimedia. When I say multimedia, or what they call multi-model, these days they use it for audio, video, etc. And the core idea is simple. They still use a natural language deep inside to do the actual calculations between this given query, let me find the right answer. But let's say somebody is asking which was the largest wildfire in Arizona, and the chatbot is able to get you the right answer. Now we just take it a step further, where we give a picture of the largest wildfire and ask it to identify this wildfire. But inside, what it does is converts it into the same embeddings of natural language and does the calculation. So this is a well-known algorithm that people use here, which if you look at this part alone, the text encoder, which is exactly the same which we have been seeing here. Give a picture of plane or a cat, plane, car, dog, etc. We do the backpropagation, etc., etc. And then we give it a new picture, it gives the answer. But this time we add a little bit more layers, where on one side we give it the image, and the other side we give the text description, like the caption from the Instagram or a Twitter post, where say, hey, this is the Pepper, the Aussie pup. So now the machine is also learning that kind of a mapping between language and vision. And then when you ask me, give them the new picture, it replies, oh, this is a photo of a dog. Now, why does it think it's a dog? That goes back into the black box, as in like we cannot completely translate these embedding mappings, but it is doing some things well, so nobody is complaining, right? So then, which brings me back to the other question, which I have been asking since the beginning of this workshop. Do you think ChatGPT really understands what it is doing? Or is it just a glorified add one word after the other kind of mechanism? Can somebody keep an eye on the chat window? I think I lost it already. Okay, never mind. Got it. Okay. So the question is, do you think ChatGPT understands language? Like a human does. Let me put it that way. No? Okay. Why?
It can, can't think for itself, but it can make decisions. But I don't know, I'm not sure.
Okay, so you're saying it can make decisions, but it is not intelligent, like humans? Let me ask it this way. What do you think humans have that ChatGPT doesn't have? What?
Blood?
No, I mean just the intelligence part of it.
Um, like, that image encoder could have been manipulated to say that it's a cat and but a human. So
Right.
that type of knowledge.
Okay, let's compare it with the newborn baby who has no knowledge, right? Is ChatGPT at the same level as a newborn baby? Assuming the newborn baby can speak. So you're saying we have like N years of learning, which ChatGPT doesn't. So do you think if you train it for N years, it will be better? Yeah, so this is the question we have been asking in our research, which I wanted to introduce here. People have been asking me about this. This is called quantum natural language processing. And all this started with this interesting experiment. So the experiment was a task which we gave to the state-of-the-art AI model like ChatGPT. We gave it 2 sentences. First sentence was Bob likes warm beer, and second sentence was Bob doesn't like warm beer. And we asked the model, do you think these 2 sentences agree, disagree, or are neutral to each other? And the model said, sure, they disagree with each other. Very smart model. Next thing we asked, okay, by the way, this task is known as recognizing textual entailment, which is a well-known task. So next thing we did was we gave it just 1 sentence and asked the question. So the sentence is Bob likes warm beer. Does it agree, disagree, or is it neutral to the second sentence? There is no second sentence, okay? So, oh, Pradnya, I just saw your reply, emotions, and it's very interesting that you mentioned it today. I'll get to the why humans have more emotional intelligence and awareness than ChatGPT. But continuing with my concept of this experiment where we tried giving it 1 sentence and we even asked a human being like, hey, here are 2 sentences. Do they agree, disagree, or are neutral to each other? And the human being said, sure, they disagree. So when we gave just 1 sentence, what do you think was the human's reply? Yeah, he's like, okay, what am I comparing it with, right? Nope, ChatGPT or one of the open source models said they disagree. So that's when it got us thinking, hold on, it's probably just memorizing that Bob likes warm beer, always say disagree. Does it even understand what it is saying? Not sure, right? So we then conducted a lot of this experiment, and this was my PhD thesis. And the point was, it is at the end of the day, a glorified pattern recognition mechanism. It understands its subtle patterns between words occurring together, because remember, it uses bag of words. There is no systematic buildup. Another experiment was we took one of these big models, generative AI models, and we trained it only on 100 sentences like this, right? Just Bob likes warm beer, Bob doesn't like warm beer, et cetera, et cetera. Just 100 data sentences. Remember, ChatGPT goes anything from 3 trillion and more sentences to learn across months. So what do you think the ChatGPT would answer if so, the testing and training thing, right? We trained it on 100 data points and we asked it a question about something it doesn't know from these. And what do you think it did? Yeah, it just said no. It just gave up. It said, "Oh no, I have no idea. You just give me 100 sentences. I need to see trillion to even understand what context is." Or more importantly, in this sentence, what it is really learning is the word likes. The meaning of the word likes is created by its occurrence with Bob, warm, and beer. Same with every single word. That's what it is doing at the end of the day. It's just a glorified frequency measuring mechanism, right? But then interestingly, we asked the same question like this to a lot of these machines, which are specifically trained for all this NLI, natural language inference, and all of them said 0.3 accuracy. It's close to random, basically. You could toss a coin, you'd get 0.5, right? So if it is agree, disagree, or neutral, okay, in this case, there are 3 classes, we can say it's 0.33. Right? So they are all just giving up saying, oh, 100 data points doesn't matter. I don't know what to do. But you ask the same question to a human, they'll say, sure, I don't mind 100. If you're telling me Bob doesn't like this, Bob doesn't like that, and ask me some related question, the human can answer, right? So why does it do that? So because why do you think humans can do that from, let's say, a small training data set while GPT needs more?
Because it's a smaller model. There's less. You're setting some different parameters there.
So when compared to human brain, the GPT is a smaller model? Okay. Well, so this is where we started off asking, so why does this happen? Like I said, all of these models need trillions of parameters, and parameters means the weights of the neurons. And it's usually exactly same as the number, or it's probably less than the amount of data you need. So maybe if this is 10 power, what is it, 12, it probably needs 1 or 2 extra zeros in the amount of data it needs to learn from. So it is trained on everything on the internet. That's probably 10 power 13 or 14. So this even somebody made up this Calvin and Hobbes thing and said, are you making any New Year resolutions for the year? It's like, no, I'm just going to wing it and see what happens. Not somebody, of course. Hobbes, who made it? Oh, no, I don't remember the guy who made Calvin and Hobbes. Anyway, so the point is, the deeper question is, how do humans learn language, right? So if you think about it, humans, we really have these, we as a baby might not know what grammar is, might not know what meaning is, but the baby understands, hey, this person is mom. She gives me food. I eat food, I am happy. So this is slowly how it is learning from all the examples, right? So in fact, this was captured historically in AI world, known as, there are 2 major schools, okay? The first school was let's learn language from meaning and grammar, like build it up like a human does. And the other school was let's learn language from the context. So until 10 or 15 years ago, it was the first school like Chomsky, Lambeck, and all the great linguists who said, yeah, language is learned from meaning of individual words. So Bob likes warm beer. Each of those words have a meaning. And then you as a kid put them all together and created this new mental model for, oh, Bob likes warm beer, or mom likes warm beer, right? So if you think about it, those were independent pieces which got combined in your head, and it took you to a bigger mental plane. That's what happened. These GPT mechanisms, on the other hand, says, oh, we don't care about these individual words, building them together. We are just going to check which word occurs with which other word. So that is what we call learning from context. Humans also do that, by the way. So if you say you're growing up and initially your mom says, hey, let's go to the bank and get some cash. But then you ask mom, okay, what is bank? And mom explains, oh, it's kind of financial institution, blah, 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 right? A week later, your dad says, let's go to the bank and get some fish. I catch some fish. Then the kid is like, okay, wait, I thought bank is where we get the money. So then dad says, oh, that's a different context. Today we are going to river bank where we are getting fish. So now, so my point is the amount of the percentage of learning you do from context is very less when compared to what you actually learn from meaning and grammar. You eventually encounter what we call word sense disambiguation, which in other words, which is very prominent majorly in English, because in English, one word can mean different things in different contexts. Not true in other languages, right? There are, if the language, older the language, it has different words, so many different words that it really doesn't have to do the piggybacking on the same word. So clearly everyone agrees we got off on the wrong foot with English, but nothing we can do at this point. But more interestingly, everybody until from the beginning of humankind until like 10 years ago, people were all saying, oh, yeah, we are learning meaning first, then we somehow know to put them together. It becomes a bigger meaning, and we play at the meaning world. But then what happened was, so these two schools of thought were called neat people, who are the proper math or linguistics people who say, oh, meanings, build it together, let's create a sentence. Scruffy guys came up and said, I don't know all that stuff, right? Too much meaning, I don't care. Let's build something that works. And this is the example I was saying, right? So where did that go? Yeah, this is Scruffy and Neat, and this is the bank example I was saying. So the school of thought first said, okay, let's learn language from the context bank. And next time it goes to another context, we'll learn from that. And this is what we call bag of words, which means you're given a big, in this case, a movie review. The first thing you do is break it into individual words. And then you try to do this frequency analysis. Which word occurred with which other word? Okay, so maybe the meaning of whimsical is the same as and occurring thrice, right? So this, you see how stupid this is, right? But this works because we remove like what we call stop words, like it, the, to, and, seen, etc. And with the rest of the words we have, it is able to make sense. Clearly, that's why we have GPT. But the idea is learning language from context enough to learn the meaning of a sentence? Like, what do you mean by meaning? Sure, you have well-formed sentence, or in this case, a well-formed paragraph. I love this movie, it's sweet, but with satirical humor. By the time you finish reading this, you understand what kind of feeling or emotion the person had watching that movie. You don't understand word 1, word 2, word 3. So in short, humans communicate in the meaning land, and language happens to be one of the medium we use. You know, there's ASL, sign language, right? People still communicate, they don't have words. So the idea is we play at the meaning space, not in the word space. I'll give it a second for you to digest. So these are the questions people in the Chomsky side of school were asking, like, why are you breaking down a sentence? That is the biggest mistake you're making. You're taking a well-formed meaning, breaking it into small pieces. Now you're trying to make sense out of the pieces because you have only parts, and you're saying, oh, this part occurs 3 times, that part occurs 4 times. So maybe the meaning of such whimsical is created from the people around me, right? So then the point they were making is, if you have to learn meaning from context alone, of course, it makes sense that you need to see tons and tons of examples before you arrive at the meaning of a word. So if the machine was learning only the meaning of bank with how many words it occurs with, maybe in all the sentences in the internet, bank occurs with the word cash. So it learns that the meaning of bank has got something to do with cash. That's not true. Bank itself is a different meaning. It's not dependent on cash. It's financial institution. It's a mental thing for us, right? So that's why if you have to really look only at the context, that explains why you need, oh, bank in bank as this sentence, bank in that context. Oh, there is a river bank. So I need to keep seeing more and more examples for that. So then the last question is that how humans learn language? Like, do we teach kids just, hey, word, okay, word 1, milk, word 2, mom? No, they kind of acquire things on their own, right? You point them in fact, the most interesting thing is them making new sentences with the little things they learn. We never taught you the meaning of something else. Like it's a recursive program, right? If you initially, we know only 3 words and the kid understands, oh, I can put these 3 words together, give me milk, you get milk. Tomorrow it learns, hey, oh, that's a ball. And nobody's going to tell you this, but the kid automatically say, give me ball. See, so we humans have this innate ability of recursion, which we can build on the things we learn. But that's not how these machines are learning language, right? So that's why it needs huge amounts of data. This is, in fact, a very deeper philosophical thought also. This person is Wittgenstein, and he's the one who said, meaning is context, but context is not meaning. Right? This is what I've been trying to say. Like, if you just look at the words around it, yeah, okay, but bank, sure, has something to do with every time cash occurs, but that alone is not its meaning. For example, riverbank doesn't occur with cash, right? So it still has a different meaning. So philosophically, that these thoughts have been going on for centuries. Like, can you build a sentence with the flow of meaning, or start with the meaning of a word, like snake? Oh, this is a snake. And that's it. Go. Next time the human says, oh, this is a ball, that's a tree. We know how to try and convert it automatically. Sure, you went to grade school or maybe middle school and you realized, oh, there is grammar. All we learned was a name for the thing which you were already doing, called grammar. You're already speaking the language. And somebody told you, oh, by the way, that's a subject. Like, sure. Object, sure. Whatever you call it, but we knew it already. We were doing it without the formal learning. You think people don't speak language until they learn grammar? No, people are just fine. We play at the mental model level already. So coming back to the question of what is happening here is the same pattern that's happening everywhere, which is we have a continuous world around us, and we try to make sense of it using discrete tools. Calculus, right? So calculus, what it does is it takes a continuous area under a curve, for example, and we break it down into small pieces and we integrate it. So that's what we are doing. We are exactly breaking the big sentence into small words and trying to put them back together. The question people are asking is why? It's already in the continuous space, right? So we have been using these discrete tools, and one of the things we got off on the wrong foot was this guy, also known as transistor. Like Schottky and others who invented transistors happened to invent a machine which talks only 0 and 1, and we suddenly changed everything into zeros and ones. But think about it, your world is not 0 and 1. There are so much gray areas. You don't either take a left turn or right turn. You can probably not go. You can probably take the middle turn, middle road, whatever. It's not black and white. But why are we just doing black and white machines? Maybe that is a fundamental mistake we have been making, and maybe that's why we cannot cross this glass ceiling of, is it really intelligent? That's this fundamental thought. Like, okay, great, but I don't think it's understanding language. It's not, because it is just numbers. It's just playing the frequency game. So even when we had Boolean logic, the thought was there is a field corresponding to Boolean logic, which people forget, known as fuzzy logic. And in that, there is no yes or no answer. There is like a gradation of answers, right? Is it hot? Yeah, it was moderately hot. It was fairly hot, right? So we are there. You see the big divide, right? There's a discrete world, there's a continuous world, and all we do is approximations of each other. In fact, if you know about computer science, historically what came first were the vacuum tubes. And vacuum tubes are a continuous model, but it was not easy to produce them in bulk. So people started using, okay, let's produce transistors in bulk. And we lost almost 50, 60 years of human life doing this, right? And in fact, if any of you play music, musicians swear by vacuum tubes, because if you're a musician and if you play your electric guitar using a solid state amp and a valve amp, what we call the tube amps, you can actually hear the difference, right? It'll be tuck, 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 which is your discrete music. And the other one is da, 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 dee, da, 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 da. Okay, sure. In the first case, you played so fast that you don't realize it. And that's exactly what MP3 does, right? So MP3, the history of MP3 was when internet came, the original music was on vinyl, and they said, okay, let's convert to digital. But even for internet, we need to remove a lot of these, we need to reduce it. So they just came in and took out all the frequencies what humans cannot hear and gave you this minimal frequency. So interestingly, there is this experiment where there's a song by Beatles, Day in Your Life, where there's a dog whistle being blown. Dogs would react to the original song and not the internet one, because that frequency, you don't even realize as a human. It's humans only hear emptiness there, but dogs would hear the dog whistle, the high frequency dog whistle. So that's the approximations we have been doing for last 30, 40 years to get here. So you might have heard of von Neumann architecture, which is exactly what a computer is now. We have a central processing unit, there is RAM, there is an input, then there is a calculator, and there's an output, right? What you won't realize is John von Neumann was the father of continuous geometry. Like this thing, he actually had papers on quantum mechanics in continuous world. So anything quantum mechanics is continuous, because we go into this world of, okay, let's get to that in a second. So the point is, when we are trying to do this, kind of break it down to words, it's just a last ditch effort. Like we throw everything at the screen, we throw spaghetti at the screen, at the wall, and we are hoping something sticks. And that's all what this GPT is doing. The more you throw, more complicated you throw, maybe it's instead of 10 spaghetti, there's 10 that is sticking, right? So now there is a piece of the puzzle which we have been missing all this while, because we are trying to understand a continuous world, and which is where all this QAI and QNLP is coming, and they call it the last bridge at the end of discrete world, and the first bridge is the continuous. And fundamentally, this is the idea. It works on qubits, not bits. So remember, bit is nothing but 0 and 1, and we got off on the wrong foot because somebody invented transistors and they realized, oh, we can encode everything we say into zeros and ones. And quantum guys come and ask, why? Why do you want to take this amazing thing called human mind, encode it into zeros and ones? It's almost like, take an airplane and you make a paper plane out of it. So that is the fundamental question, because qubits are not particles. They're both particles and waves. They're actually waves. And one of the and zeros and one is only one of the states that they collapse into. So you might have heard of this word, what is the duality theorem? The particle and wave duality theorem, right? So at that level, it can be if you want it to be a particle, it'll be a particle. If you want it to be a wave, it's a wave. And there's an interesting fundamental thought also in philosophy, which says, how do you know you are this body if you're not conscious? In your sleep, are you this body? No, you're going somewhere else. You're just a wave. It's the consciousness which is making you wake up, right? But you might, for all you know, you might be a wave and you're being projected into this 2-dimensional, 3-dimensional plane. How do you know? Like if you are born without 5 senses, how do you even know you're on Earth? You might just be a wave. So that's very close to, like, actually, if you think about it, it is very close to the whole idea of meaning fundamentally. So a meaning of a word hat can have so many rich meaning, right? So the one meaning changes based on the context. A bit cannot capture that. So every word is so rich, it has so much things behind it, so much meaning behind it. So fundamentally, we were doing it wrong using just bits, but these machines are meant to capture our human brain more deeply. So how does QNLP do it? Like, I know only QNLP, I don't know what QAI does. So what it does is it starts by meanings of words, builds them together, does what we call entanglement, which is a concept in physics. Like each qubit is a word, then you entangle it together. And now you realize that normally people would say, I love ice cream. And even for ChatGPT, those are 3 independent words. But as a human, when somebody says, I love ice cream, like, oh yeah, that guy knows ice cream. There is that aha moment, that guy loves ice cream moment. Like Alice loves Bob. Oh, I didn't know Alice was dating Bob. That kind of stuff, right? So that is what the magic of entanglement does. So we realize you put these words together and do magic known as entanglement. And suddenly the machine is able to understand, oh, Alice loves Bob. It just needs one sentence. Really, if I tell you Alice loves Bob, and you just need one sentence to understand the concept. So these machines, in fact, are doing all these amazing things. So it takes the rich linguistic meaning and combines it with structure, just like a human does. Internally, this is what we do. I prefer the morning flight through Denver. It is a mental model. Sure, at grade school, you call the subject, object, blah, blah, blah. Nobody cares, but we internally knew what it is. And in fact, their argument is grammar, when we knowingly or unknowingly use grammar, we are actually mediating the flow of meaning between the words. You see the difference, right? So independent words, Alice loves Bob. You're putting it together, you're counting how many times Alice occurs with Bob, but there really is a meaning which translates. Alice is a person who has this wave of love coming to her towards Bob. See the big difference? Discrete words versus continuous steps. So that is the core idea of QNLP. So I won't bore you with all the physics side of things. I'll give you one example of what it did recently. So this is the LLM model. So what I did was, to the QNLP model, I fed LLM as the input. And I did the same experiment, which is just the 100 data points. Like Bob likes warm beer, Bob doesn't like warm beer. Remember, the AI models were failing miserably. QNLP gave 100% accuracy just with 100 data points. It's just like a human. It just says, oh yeah, okay, I don't need to know Alice loves Bob. To know Alice loves Bob, I don't need to know all the Alices in the world and what all the Alices are doing. I just need one sentence. Alice loves Bob. Okay, sure. Right. So, and the priming is, who is Alice? What is love? What is Bob? Maybe that is helping. But either way, what we are doing is taking it close to human language acquisition. Can it be done with classical? We haven't reached a point where we can come up strongly and saying that, okay, this is something only QNLP can do while classical cannot. Trying still. So if nothing else, it's a baby step. And that is the work I've been doing. Clearly no publications because it's so esoteric and out of the normal thing, what I call fools rush in where angels fear to tread. And that is the kind of thing interests me. So I'm also working on with Roger Penrose and Hameroff on quantum consciousness. This is a very interesting idea. Remember in the previous class, Brenda was saying, we have neurons. The neural networks are modeled after neurons, and that's why these neural networks do amazing things. But all these researchers in the neuroscience, the actual neuroscience, knew this idea that, oh no, the information is not transferred through the neuron. There is a layer deep inside known as microtubules, right? So sure, if you take only the outer, if you put like 2 or 3 plants next to each other, sure, they are transferring water to each other, but the actual transfer of water happens somewhere very deep. And this is well proven by people like Roger Penrose that this is how our human brain wakes up, right? So when you go to sleep, you go back to the wave, and then you suddenly collapse into this body when you wake up, right? That's exactly what happened. That's consciousness. So now what we are working on is, can we reconstruct microtubules using quantum circuits? Completely out of the world. So which is why I said fools rush in where angels fear to tread. If you're interested, there's a department here known as consciousness.arizona.edu. Go check it out. You will see more crazy things than this there. But that is all I have for you guys today. So yep, 53, so 5 more minutes left. Questions? Oh yeah, emotions. So we just had a meeting with the head of psychiatry today where we were saying, yeah, but how do humans learn emotions? Is ChatGPT emotional? Right, when we are breaking it down to what is an emotion, where does it occur in the human brain? Is it associated with consciousness and things like that? And if yes, can you train a machine made with zeros and ones emotions? Can you train a machine trained with continuous waves as emotions? So interesting routes if somebody pays for it, but we'll see. Yeah, so thank you. I'll open for questions and thank you for being in this lecture series.